Good morning, class. This is Dr. Irani, and welcome to my first ever live tutorial using Zoom. If you see any difficulties, the best thing to do is send me a chat, or even better, use email. And besides, I have used on Blackboard, I've created like a forum discussion, so you can always post your questions over there. So today's lecture essentially is to walk you through the TOAST Kaizen operations analysis charts and to give you a sense of what we had done a few years ago as regards creating the different charts after watching the video. So I think that your watching the video is very important because everything in this chart or these charts essentially has come off of that video. So you can see now the importance of doing a project in industry. You're kind of over there observing things, and that's the best way to then start documenting. Once you have the video, you can run it, pause it, and then you can break it down into individual activities. So what you see here, what you see on this first page, page one, in that output, is essentially your flow process chart for the current state. So this is the current state where the process took about, I think, 4.5 minutes. Now, this flow process chart that you see is a lot more detailed compared to the one in your textbook. So like over here, you can see that there are descriptions of location. That's the kitchen where the process was observed, right? Then what was the activity? The toasting of the bread. The date on which it was observed. You can see 2010, so this was quite a while ago. Who are you tracking? That's the operator, the worker, right? Then who is the analyst? Shijie Wang. She was my PhD student. And then over here are, what are the methods you're basically tracking, okay? So, and then over here, the summary, this actually comes after the process is completed. But again, you can see that this is like a summary of the total distance walked, number of feet, the total time that was taken, how much was the value added time, how much was the non-value added time. Takt time, of course, is an option. If you're trying to design an assembly process, then yes. What you see over here is a summary of the entire process. So you can see number of operation steps, number of delays, number of inspection steps. This is slightly offset, again, God bless Excel. But you can see that over here at the bottom are the different activity elements that typically are recorded in a manual process. And this is a summary. Now, what I would urge you when you are working on your TOAST Kaizen assignment is these bars should be the time, the total time spent doing operations, the total time spent waiting, the total time spent in inspection, the total time spent in transportation, waiting in inventory. And then, of course, this is a decision block. If you really want to get sophisticated, then you can have a double bar chart. So you can, for operation, you'll have two bars. One would be the number of operation steps, and the other column would be the total time spent in the operation steps. Okay, so now let's go down here. This is your basic chart. So again, first column is the activity. The second set of columns are the different activity elements: operation, delay, inspect, transportation, waiting, decision, right? So every step, every row in the spreadsheet is a step, and each step is qualified to be either operation, delay, inspection, transport, inventory, decision. And then these are the standard columns. You see, time, total time taken for that step is 3, total distance traveled is 4. And then over here is where you put little observations, like you just put in your comments. I saw some difficulty, or hey, there's an ergonomics issue. So this is basically for you to record as you're performing the step issues which you encountered. Now go back here. Remember we did value stream mapping? So do you see that compared to value stream mapping, this classical industrial engineering chart is not that good at recording all the data. So there are two challenges. One is that when you have an operation step, you would like the data columns to be changeover time, cycle time, first time through, quality, uptime of the process, right? Number of operators, is it semi-automated? So these two columns are really not capable of capturing that information. On the other hand, when you have a transportation step, then you may want to capture distance, the time it took for the transportation step, but then you also wish to capture details like what was the equipment that was used, was it immediately available, did the person have to go search for it? So I think what value stream mapping gives you is the ability to take these 30 steps and then put a data box beneath each step. Depending on the step, you can capture the data you need for that particular step. Now, inspection probably would have the same information as operation. There's a certain amount of time it takes to set up the inspection equipment, a certain amount of time to do the inspection. Then there are issues of what is the efficiency? Does the inspector always perform the inspection step with 100% efficiency? Is the inspection equipment always available? That is the uptime. So that is the challenge. Now, when you look at the video, again, this was when we observed it, we broke that video process into 30 steps, 1, 2, 3, 4, 5. And you can see for each process step, we qualified that with transportation, operation, transportation, transportation, operation, transportation. That's basically how the process gets documented. So this is what is most important. This is the heart and soul of your first operations analysis chart. Kind of it's the core, the flow process chart. So what I would urge you to please do is, whether you have or have not observed the video, that's okay with me. I know you're in charge. But when you observe the video, try to see it as a team, and then as a team, try to convince each other, hey, you know what, that's right. This is actually a complete step. This time, start time and finish time corresponds to transportation. So if that happens, convince yourselves that there were these 30 steps which were performed. And then, look at these columns for each of the steps, and you decide for yourselves, okay, are these comments valid or not? Okay, so that's the first chart which you would create to document the current state of the process. Next. This is the next page, page 2. You can see is your, improved process flow chart. Again, same data, right? So in this case, the process is proposed. Once again, it involves the resource, the worker. So keep in mind again that, when you create flow process charts, it's the operator, it's the product or the material, it's the equipment. In some cases, it may be information. So this structure of the flow process chart is way better than what the textbook has presented to you. Once again, you can see that this is like a summary chart, and you have basically got the total time and distance characteristics of certain steps and the number of individual steps. And you should be able to see that between the current state and the improved state, there's a difference. Let me go and show you the spaghetti diagram for the current state. So this current state spaghetti diagram, all that it's capturing is there are different objects being tracked. So this is the blue arrow captures the person's movement, the red arrow captures the product's movement, the brown arrow captures the plate. It's like a fixture, like a tool. This captures the material. I think there are other charts, right? There's a knife involved. So what you're essentially doing is you are looking at the flow process chart, and every time there's a transportation step, you're asking, okay, what is being transported? Is it the person only, or is it the person with the plate? Is it the person with the butter? Is it the person with the bread? Is it the plate and the buttered toast being taken to the door over here to ask the wife, honey, the toast is ready? So what the current spaghetti diagram is doing is it is only mapping the transportation steps that were captured in the flow process chart. Now you can see again that Once you have a spaghetti diagram, you look at things like travel distance, look at things like crisscrossing, you look at number of trips which are back and forth. You can see very clearly that the current state of the spaghetti diagram is showing a lot of transportation. So once again, remember all these operations analysis charts are connected to each other. The spaghetti diagram, the spaghetti diagram basically helps you to visualize all the transportation steps in the flow process. Okay, so that's the second chart which you create. Here's the improved spaghetti diagram. So again, what I urge you as a team is when you sit down with the video and you're observing the current state or the future state, try to convince yourselves, oh, this spaghetti diagram is appropriate. It correctly captures all the movements of the individual entities in the actual system being monitored. And then I think for your assignment, I'm quite okay if you use these solutions as a basis to create your own solutions. You know, you draw your own layout. It'll be very simple, and I'm okay with you essentially saying, you know what, yeah, what I see here is the same as what I saw when I watched the video with my team. And so these results can be essentially transferred into your assessment number 5 solution. I have no problems with that, guys. I'm not gonna come after you for plagiarism. In this case, I'm encouraging you to use past work as a basis for improving, and who knows, the assignment you submit could become the next version of this teaching resource, which is offered to future classes. Okay, so we go through this process, and pretty much what you will find is that when you create the flow process chart, the whole idea is, from a lean mindset, is, hey, where is the waste, correct? So that's what these pages 5, 6, and 7, essentially, 5, 6, and 7, these 3 pages in the handout, essentially do. I look at every one of the 30 steps. I take the activity exactly from the flow process chart. And then over there, the third column is the type of waste. Remember, the whole idea of process mapping are 2 things. Minimize the waste, because then that minimizes the cost. And appropriately, when you minimize the waste and you improve the process, you're trying to minimize the total time it takes to deliver the service to the customer, correct? So this was something which we did. Again, I was teaching, or always been teaching with this resource. So this spreadsheet or this table is essentially drilling down into the details of flow process chart analysis, something which the typical textbook doesn't teach, but Lean motivates. All you do is you take the flow process chart, document the type of waste, and then you write these recommendations. In a value stream mapping context, each of these recommendations would be a Kaizen burst on the process map or the value stream map. So please, again, when you are going through the video, sit down with your team and discuss these items. I'm leaving the learning to you, but if you think that things are not well done, I urge you to basically say, look, my team is going to produce the next version of this teaching asset. Okay, so go ahead, the same 30 steps in the flow process chart, but now that entire flow process chart has been expanded to look at purely the type of waste in each step and the Kaizen burst recommendation for each step. Okay, so here we go next. Now comes this chart. This chart essentially is, I would call it a tree diagram, tree, T-R-E-E, tree diagram. And the way it goes is, when you look at the process, really there are 2 constraints. And I think that depends on who's watching the video and how they are thinking. Now, if you look at the video, you've been made to think that the constraint is the toaster. You're clearly being made to think that, right? Because the guy's waiting, he's dawdling around, he's looking into the toaster, looking out the window, moving around his plate, right? But go back and look at the current state. When the toast gets done, and he puts the toast onto the plate, and it's time for him to apply the butter to the toast, you will notice that he found it very hard to cut the butter, right? He was using a butter knife which does not have a sharp edge. That butter knife needs the butter to be soft in order for it to be useful to apply butter, right? And then secondly, he did not know how much to put. So because he was not able to cut, there was no standard quantity as far as how much he should apply to each slice of toast. So that's why what I did here was I basically took all my thoughts and I said, okay, if I look at theory of constraints, and theory of constraints says, look, if you're not exploiting the constraint as the first step, if you're not looking at the bottleneck in the system and making improvements to improve the constraint, then you're wasting your time, right? So is the toaster the constraint or is the butter the constraint, right? Now, somebody says, yeah, the toaster is the constraint. So you say, okay, why do you say that? Because there's a problem. The toaster cycle time is high and it appears to be burnt. Okay, so I said that the toaster is a problem. Why? Because clearly the toaster cycle time was very high and there was a problem because the toast seemed to come out burnt, right? Then over here, the thought is, well, if I know it's a constraint, why? Because again, I'm burning electricity. I mean, there are two sides, two slices on each side. And again, the question is that why am I running the full toaster at full capacity when I should not? So once I see the problem, then I ask, how am I going to fix the problem? So in the case where the cycle time is very long, in the case where the toast is getting burned, I'm basically saying, okay, check the toaster settings, right? So that's, I'm going from the problem and justifying why it's the problem. And then once I know it's a problem, I'm saying, how do I solve the problem? So how I solve the problem by checking toaster settings. How do I do that? By doing something. It's called a work breakdown structure. So try to take this tree diagram and understand why these entries have been put one below the other. So take this case. Is butter the system constraint? Yes. Why did I say so? Because it was hard to cut with the knife. Okay. Now, how do I eliminate that constraint that it was hard to cut with the knife? I warm the butter in advance. Okay. Then the question is, how much time will it take? Because when you decide how much time it will take, then you understand, well, could I have microwaved the butter? In which case it's an extra step. Or do I just leave the butter outside overnight? And that's exactly what they had done. If you notice, when they began the future state, the butter had been out for a long time. And so the butter was soft. So basically what happened was they eliminated the potential for the butter to be the constraint. Now, go back. How do you know that the butter is the constraint and not the toaster? That will be from a lead time perspective. That is where the Gantt chart and the observation that it was hard to cut the butter should both be used together. So basically what you're saying is, look, the total time it takes me to toast a slice of bread, I have to compare that lead time, that longest path component of the project, with the total time it takes me to prepare the butter for it to be applied. Whichever is the longer of the two times, that basically is your constraint. So these charts, if you do not create a Gantt chart, which shows a timeline of all the individual activities and their durations, start time, duration, finish time, your process improvement activity is compromised. And so again, I don't think in the lean literature, I don't think in the textbook, they have shown you all the elements, all the charts and analyses you should do. So what we tried to do here was to create a total collection of charts. So flow process chart, spaghetti diagram, constraint analysis, which involved 5 whys and 5 hows. And then finally, the one to look at is the Gantt chart. So, we use Microsoft Project, and again, Project is not exactly a scheduling tool, but all we try to do here was, there are 30 steps. You put a start and a finish time for each step, a duration for each step, okay? And then you put a precedence, meaning that this activity can be done before that activity, and then the software basically creates this project Gantt chart. I don't think it's very helpful. It almost looks like, in this case, you are just documenting the process. So this Gantt chart is not as good, but again, this is the Gantt chart for the current state, and this is the Gantt chart for the future state. You can just see that you went from 30 steps to 14 steps, correct? Uh, but again, from the structure, again, you can see many activities are small, and the constraint process is the toaster. So the Gantt chart, again, is a very good visual mechanism to show the bottleneck, something which the other charts do not. Now, what I will show you next is, open. So this is the Gantt chart I would like you to see. Uh, I know it's not very clear, but I'll do my best. Please bear with me again. I will do my best to explain to you how this chart was created. Actually, full credit goes to one of my undergraduate students. So when I was at Ohio State, I taught them all this stuff about resources and sequencing and scheduling, and the whole idea that this TOAST Kaizen is not really as simple as people think, and that the TOAST Kaizen is actually a complete teaching module that could be used by any teacher, any student to teach other people about, hey, this is what we industrial engineers do. We take a system or a process, we videotape it, we create a four-process chart, we create a spaghetti diagram, and we create a Gantt chart, and then we use these charts together to decide, okay, so how do we go about making our first improvement? So the first spreadsheet here is, you can see here, these are all the steps, right? These are all the individual steps which were done in the order that they were performed. Okay, so these step numbers 1 through 30 will come from the flow process chart, but the activity sequence, since he has to draw them in a certain sequence, he has sequence that you can see, start time and duration. So start time plus duration will give you the finish time, right? And that's telling you what is the resource. Is it the bread being touched? Is it the butter being touched? Is it the knife being touched? Is it the plate being touched, the toaster, or the worker? And in some cases, you will notice it's a combination. 2 or 3 of these elements all have to be touched at the same time, and that is where the coordination and the resource availability becomes an issue, correct? So here's the Gantt chart, and again, let me talk you through an example. So the font is small, but let me start with one activity. So let's look at activity 1. Okay, activity 1 is walk from toaster to bag of bread. So that is only the person, right? That activity is only what the person does. So that is captured here. Okay, so the person walks from the toaster to the bag of bread. Right? He was standing there and he rubs his hands and he says, okay, let me make a slice of toast for my wife, correct? Activity 2 is pick up bag of bread. Now, pick up bag of bread connects the worker to the bread, right? So therefore, activity 2, you will notice, is on the timeline for both the bread and the worker, correct? 2, 2. So then what does the Gantt chart say? The Gantt chart, third step it says is take back of bread to the toaster. So again, that is the same thing, bread and person, correct? So that is 3. So now do you see what's happening? How the connection from the Gantt chart to the flow process chart is being brought about? You have 30 steps, 1 through 30 steps, right? In the flow process chart, you basically put the steps 1 through 30 from top to bottom because that is what the spreadsheet says. What that structure doesn't capture is that time moves forward. Time moves forward. So think about that. Could the flow process chart and the Gantt chart have been drawn together? Hey, I think that if somebody were a software developer, I think that those two structures could be combined. But right now, the flow process chart is separate from the Gantt chart. All that you have to understand here is that in the Gantt chart, you are taking the flow process chart and every one of the 30 activities is being mapped as a time going from left to right. So every activity occurs between 2 points in time on a timeline which goes left to right, and then every activity is being mapped onto the resources. So now you can see where different elements of the production system are waiting or bottleneck, right? So if you look at it from the product point of view, the product point of view will be bread and butter. If you look at the resource point of view, it's the worker. If you're looking at the machine point of view, it's the toaster. If you're looking at the tools, the knife. Guys, can you one? I hope can you keep the volume down, please? Anyway, but chat. Okay. Okay. I let me finish my lecture and then we'll basically hold a Q&A session. Okay. At this time, that's pretty much really the end of my first lecture. I'm sorry if I was confusing, like that's why I think that either email me or let's use the forum I've created on Blackboard. But for those of you who are doing assessment 5 for a grade, or for those of you like the Syntas teams and possibly also the specialized manufacturing team, if their project gets fleshed out, you can do it as a voluntary thing. Why? Because if you take this exercise and you can do a new version of it, I think there are lots of errors and inconsistencies in different charts. You can modernize them, and especially if you can do it with EVSM, then it will be much more. But at this time, that's pretty much the lecture portion of today. And now what I'm going to do is switch to. Let me minimize this. Okay, chat. Okay. Whoa. So your screen is showing future state Gantt chart. We are not able to see the second screen that you just explained. Could you type in, please? Mohammed, could you type in, please? We are not able to see the second screen. Which one?
Professor, I think what he means is that your screen is stuck on the future state.
Oh, okay. Let's see. Let me go here.
I think you just scroll up.
Is this the one? This is the future
Yeah.
state, right? This
Yeah,
is the
right.
current state.
Yeah.
Good. Okay, go ahead. We can talk now. I think I just heard Arul's voice. So if you have questions, we can just talk verbally. I don't think that that's any limitation. Questions? No questions? You got this part? The Gantt chart? 30 steps?
Yeah.
Huh?
Yes,
This is, you know what, guys? This is, I keep telling you that industrial engineering, science misses certain things, and the lean thinking and the lean toolkit misses certain things. This is where I think is the connection. I don't know that we have the tools available that would take a flow process chart and be able to create a Gantt chart like this. But you can see that the Gantt chart is a very visual representation of how product, tools, machine, operator, they all get connected to each other. And you're shown as, okay, one second. Somebody raised their hand. So, Awais, you want to speak up?
Yes, Professor. So, can you explain the part in which you were saying the person touches the bread packet, and that part again using this specific screen, because the time you were explaining.
Gotcha. So are you seeing my screen which should say data file Gantt chart? Are you seeing a spreadsheet?
Yes.
Good. So look here, look at your flow process chart. This is step 2. This is step 2 in the flow process chart, right? What does the flow process chart step say? That step is described as pick up bag of bread, right? So he goes to the cabinet, countertop, right? And he grabs the bag of bread, right? To bring it to the location where he'll take out 4 slices and put them on the plate, correct? So that activity connects the worker to the bread, right? Bread, worker, bread, correct? So step 2, you see the number 2 here? For that duration of time, step 2 makes busy the bread and the worker. That's step 2. So worker, step 2, is handling the bread in step 2, and that's the joining in the Gantt chart. There's a chat question. Sir, we are not able to. No, that's the point. You have to see the flow process chart. I've sent you these files. So I have sent you these files in advance. my hope is that you have them open, on your laptop. So sorry, but I know that somebody's saying we can't see the flow process chart. Okay, let me go back here. That's your flow process chart. If I go up here, you see, okay, it's very small. Forgive me. Let me see if I can zoom.
You can maybe zoom into it
Yeah,
slightly.
I was trying to do that.
You can just press Control and scroll up.
This is okay. Okay.
First, you can just press Control and then scroll up on your mouse. That will zoom
Okay.
in.
Now see, I'm looking here. I'm trying to blow that up to see it in a. I'm trying to magnify this step. Pick up bag of bread. That's step 2. Do you see the flow process chart?
Yeah.
I don't know. Do you see this chart?
I mean, I have it on my computer, so I can see it.
Okay. Okay. Anyway, this step here says pick up bag of bread. This step is step number 2. It says pick up bag of bread. So if I go to the Gantt chart, you see step number 2. Step number 2 is pick up bag of bread. So who are connected by that step? The bread and the worker. So that's why the step 2, for that duration of time, which is the time it takes to grab the bag of bread, at that time the worker and the bread are joined together and they are both considered busy. So if the worker is called away to do some work and the bread was pulled away by the kid to make some sandwich for the picnic, neither the bread nor the worker is available, that particular step could not be performed. So whatever schedule you produce, if in that schedule there's a step which says catch or grab bag of bread, unless the bread is at the location that the person is going to, that activity will not consummate successfully and there will be a delay. So step number 2, pick up bag of bread, connects the bread and the worker. That's why you'll see step number 2 is shown on the timeline for the worker and the timeline for the bread. That's basically the idea of the Gantt chart. So, when you have, for example, the activity where he is standing near the toaster, right? So there you will show that the toaster is busy, the bread is busy, and he is idle. So the timeline for the worker, for the duration of the schedule where the toaster and the bread are busy in action, the worker will be shown as not, there'll be no timeline showing on his timeline that he's busy in that period. That will be idle time, and that's a non-value added time. That's called waiting waste. And you'll go back and say, okay, that's a waiting waste. What could he be doing in that period? And that is why you'll see in the future state, he's doing things like loading the dishwasher, starting the dishwasher, then going and cleaning the sink and other things like that. So a lot of scheduling is intended to minimize the total wasted time of the resources, like the machines and the operators, and the working process, which is for the products. So the Gantt chart is the best representation available to take the flow process chart and timeline it to understand where different tools and products are either in a value added state or a non-value added state. That's pretty much it, guys. Nothing high tech.
So do you think maybe we can, there's another way of showing following a chronological order, as
Yes.
in how the process is happening,
Yes.
but
Yes.
a way of showing what resource is utilized at that particular time. Like for instance, you said pick up bread,
Right.
pick up a bag of bread, right? So the bread and the worker are both utilized at that time, and the
Correct.
toaster and the butter are not.
Correct.
So maybe we can add columns here to show what resource is utilized and during that step. Would that make it more clear? Maybe.
Absolutely. See, I mean, personally, what I would like to be able to do is to take the flow process chart, which is showing all types of activities, right? and show them on a Gantt chart way. See, the time moves forward, correct? So time has only one direction, left to right or top to bottom. If you want to show the time scale, it's a straight line. It goes in one direction. So the flow process chart would have the timeline go from top to bottom if you decided to show the Gantt chart vertically. And if you want to show the flow process chart on a Gantt chart, it would have to be placed horizontally. So I think the struggle here is that paper is basically flat. So if you are going to say every column in the spreadsheet is going to be an activity, then the y-axis will become the time. Problem then is that if every row in the spreadsheet is capturing a step in the activity, you don't know where will you show the assets being touched. So for example, if there is a step and the step says toast the bread, that requires 3 objects to be tracked: bread, toaster, and person. How will you show that if your chart has the structure of a flow process chart? Because there, every row is captured as an activity, and then that activity will touch different assets. But the y-axis, the x-axis is the activity number, and the y-axis is time. So somewhere in the cell, you will have to put something like, bread, person, and toaster. So I'm looking to you for ideas. Personally,
like for instance, in the table that's you currently showing, in this table, we can just add one more column to it.
Yes.
And instead of writing butter, bread, and all, we can maybe add a symbol for bread, butter, toast, or burger. Okay. There are 4 symbols right now.
Okay.
And so one column will just show the symbols that are being utilized. So for instance, pick up bag of bread. We'll just on that column there'll just be a picture of small bread and the burger. That just shows you that these 2 resources are being utilized.
Sure. I mean, like, see, keep in mind. So just as what you're saying is in the flow process chart. So you've got an activity in each row. Then the next set of columns are capturing what type of activity that is. Correct?
Yes.
Okay. Personally, I believe that you can combine those 2 columns. That means you can have only one column for the type of activity if you had a pull down menu. So first column shows the activity description, right? Second column, you could have a pull down menu where you choose one symbol from the 6, and all that cell will show will the particular activity. Right now you've got 6 columns, 5 of them are blank, and one of them you mark to say, okay, this activity corresponds to that type of activity, correct?
Yeah.
So okay, it may be hard to speak you through it, but to your point about the resources, what you could potentially do is you could have a set of columns beside the activity symbols, and those columns will be worker, bread, plate, knife, butter, right? And then you could black out or mark those columns and say, okay, this step touches the following columns. This step touches the following columns. So if you have, say, columns for bread, person, plate, butter, and knife, then the activity where you say, go to get butter, you will only mark person and bread. And that could be how you capture the resources touched into the flow process chart. Mm-hmm. And your y-axis will continue showing a timeline for that particular activity.
Okay. Yeah.
One suggestion would be that hand sketch your idea and email it to me, and then what I'll do is when I reply to you, I'll say reply all, and then everybody in the class will get my answer. So not a very sophisticated way to communicate in today's day and age, but at least we'll make sure that everybody remains in the thread on that particular question. That's one suggestion. I think a better suggestion would be that go to your forum discussion on Blackboard and attach a file to say here's my question, and then when I reply, everybody in the class will basically see my response and your question with your suggestion. So that's another way we could communicate. That's pretty much it, guys. If you have any questions, let me know. If not, I guess this class. Okay, yes, I got it. Thought you were showing me the video. No, again, I don't know if you got the. Maybe I was not clear in my email, but what I was hoping was that you would see the video before you came to the class. Sorry if that came too late, notification-wise. But what I urge you again is that sit down as a group. Well, if I don't know, let's see. Oh, let's use his hand. Yeah, let's go ahead. Hello?
Where is the decision block coming into effect? I think we're not using in this.
Correct. I agree. See, here's the thing that that's a very good question. So the decision block would essentially spawn. Remember, you had one column that captures this process, steps 1 through 30. So the decision block would basically come in. I say you have a decision and you say, okay, after step 7 is performed, I take a decision. Now what will happen is you will create, going further down, you'll have a split spreadsheet, and after decision block, to the left of the decision block will be a continuation of the process, and then to the right of the decision block will be another set of rows and descriptions which will capture the appropriate description of the steps for that alternative process. Gets very complicated. And I don't know if the flow process chart on a spreadsheet is the best way to do it. I think that when you have decision blocks, the flow chart is a better representation. So basically, on a sheet of paper, you write individual steps 1 through 6. Then after that, you put a decision block. And then if there's a split, the decision block continues to the left, and you again write a whole bunch of steps. And then to the right of the decision block, you create an appropriate sequence of steps. So I think the spreadsheet is not your good catch. The spreadsheet is not a very good format in which to capture a process with multiple decision splits. Good question.
Professor?
Yes, sir.
If there was a comparison done between value stream mapping and the process flow chart, then how is this? Is this better than value stream mapping?
No, see, personally, I believe that all of these charts, they have their merits, and I think you have to be careful about using the right chart. So, what does the value stream map do? The value stream map basically captures a process with all the information flows. What you see, the flow process chart is a little more detailed. So what the value stream map doesn't show is all the non-value added steps. So if you want to combine the flow process chart with the value stream map, all that you end up pretty much doing is having a bigger chart. So that, you know, if you were drawing this in a value stream map format, what you would do is you would eliminate all the weighting and other steps, and you would only look at the operation steps. And the operation steps would become the skeleton for your value stream map. And the transportation steps would connect those operations. I can easily, in a value stream map, I can easily put a decision block and split the value stream. I think the value stream map is effective because it captures the information flows that the flow process chart does not capture. So my suggestion would be that the flow process chart is more of a, let's look at the material flow first in its current state. Let's recognize all of the non-value adding steps, take them out. What is left will be your value adding steps. That is what you would put in the value stream map. There's actually, personally, I believe that you cannot improve processes and systems just by using a flow process chart or a swim lane diagram or a value stream map. I think depending on the problem you're trying to solve, the system you're trying to improve, you have to kind of have a discretion to say, you know what, I will use the value stream map for this much. I will use the process map for this. I will use the fishbone diagram for this. I will use the flow chart for that. I think it's just a question of know all the tools, but then depending on what you wish to do, you be more judicious about the particular tools you use. That's all I can say. I don't know that I want to give like, oh, this is God's word. That's exactly what you do as far as when to use the flow process chart and when to use the value stream map. My thing would be that the value stream map is best used when you clearly know there's a production system being improved. So like, okay, I want to make sure that I'm packing so many uniforms per hour. Okay, that is your system, a syntax. Now you create a value stream map. And then the value stream map below it will have a flow process chart and a spaghetti diagram, because those will capture all your non-value added work. You do your best to eliminate the non-value added work, because if you did not do that, you could not do all the line balancing calculations, takt time calculations that value stream mapping will expect you to do. So I think process improvement should come before value stream mapping. Sorry, I don't know that I gave you the best answer, but as I said, I believe that there's a good in every chart, and that we just over time have to keep using them to learn, aha, in this situation, I will use that chart and that chart. I don't want to give you a definitive guidance that you only use value stream map in this situation. I think you should understand, look, if I'm trying to improve a process that may or may not have a repetitive nature, then a process map may be better. Flow charts may be better. Flow process charts may be better. If I have a clear repetitive production or performance of a service, then I think a value stream map would be better. So be broad-minded, use all the charts. Sorry, I mean, what I would say is, look, again, this is the kind of stuff where I keep telling you students that, look, those of you who may be interested, if you work with me over time outside of your coursework, I can teach you what I'm saying. I cannot in a lecture in a single course. I don't think I'm able to teach it to you. And then with this pandemic situation and social distancing, it's a lot harder. But all I can say is, no, stick with me, keep communicating with me, take on other projects outside the course with me, and I'll teach you my stuff. But to go back to your question, there's no golden rule. Oh, in this case only you should use value stream mapping, and in this case only you should use spaghetti diagrams. They all get used together. Okay? Oh,
Thank you, sir.
There's another question. Chat. Okay. Can we think of the chart on the last pages similar to the root? Absolutely. The chart where that constraint-based thinking. This is Aves's question. That can we think of the chart on the last page is similar to the root cause analysis? Absolutely. That bubble diagram which you see is a combination of what is called 5 whys and something that they call a tree diagram. So a tree diagram is basically saying I put the problem at the top of the tree, and then I ask, how will I solve the problem? So you put, like, say, 2 answers, right? Answer 1, answer 2. Then you say, how will I execute what I said about doing answer 1? And slowly what you do is you create what is called a work breakdown structure. So you're absolutely right that those charts which you saw, they're kind of a root cause analysis, but they don't stop at cause discovery. After the cause is discovered, they continue by saying, okay, now how do I find the solution to this cause? So it's the top half of the tree is cause analysis, and the bottom of half of the tree is action to eliminate the causes. But you're right. It's basically start with the problem, the constraint, and then why is the constraint happening? And as you find out the cause or causes, you say, okay, how do I attack the causes to eliminate the reasons why that step or that system is a constraint? Absolutely. Yep. Questions? No questions? Hey guys, I guess that's our first lecture. We'll probably meet again like this next week. Maybe next week we could discuss projects. If you want to discuss projects, then what I ask is send me a PowerPoint, and then I'll open it up and I'll discuss your PowerPoint for that team. I promise you not to be critical. I'm not going to embarrass anybody, but that's something which we could do. But the class, please tell me what do you want to do with each such meeting on a Friday. I'm completely at your service. I know that you all are facing a lot of difficulty because I think a lot of you have on-campus jobs that I don't know if those jobs have now disappeared with the situation. So look, I'm not trying to be a bigger problem to you, but please understand I have to continue the class and be fair in who I give an A and who I give an F. Not that I want to give any people F, but just seeing how many people are attending today is indication that some people are taking this course seriously and others are not. I'm there to help you. You just have to email me or like this participate on Zoom or go to Blackboard and on the forum discussion, put your question. I will respond with an answer, send attachment files. Let's do our best, cooperate with each other and take care of each other. Okay? So if I don't hear from any of you, I will say bye-bye, good night, ta-ta, good afternoon, and have a good weekend and be safe. Okay? God bless. See you guys.
Thanks. Bye.
Thank you. Bye, sir.
Bye.